All right, welcome back. You know that feeling, right? You're driving, you put your foot down, and you just wish there was a little more kick, a little more oomph. It's a feeling pretty much every driver has had. Well, today, we are going to dive into the amazing little device that gives you exactly that, the turbocharger. So this really gets to the core challenge for any car engineer, right? How do you get that thrilling performance, that power, without having to build a giant, heavy, and super inefficient engine? It's a puzzle they've been trying to solve for decades. You see, the dream, the holy grail really, for any engineer, is to get big power out of a small engine. I mean, that's the best of both worlds, right? You get great performance and good fuel efficiency. But how is that even possible? Let's take a look.
Well, the answer, in one word, is the turbocharger. Now, you've probably heard that word thrown around. Maybe you've even seen the little turbo badge on the back of a car. But what is this thing, really? It kind of sounds like something from a sci-fi movie, doesn't it?
Okay, so when you boil it all down, a turbocharger is basically just a really powerful air pump. See, an engine makes power from these tiny, controlled explosions, thousands of them every single minute inside the combustion chamber. And the simple rule is, the more air you can pack into that chamber, the more fuel you can burn. And more fuel means, yep, more power. The turbo's job is to just cram a whole lot more air in there, essentially supercharging the entire process. And what's really fascinating here is how simple the core idea is. You know, for a device that does such a mighty job, a turbo is really just two small fans, or wheels if you want to get technical, and they're connected by a single shaft. That's it. Let's break down those two parts. So, on one side, you've got the turbine, and the absolute genius of the turbine is that it's powered by something the engine is literally just throwing away: hot exhaust gas. All that wasted energy is used to spin this turbine at insane speeds. Then on the other side of that shaft, you have the compressor. And since they're connected, when the turbine spins, the compressor spins. Its job is to suck in fresh air from outside and squeeze it or compress it. It's this beautiful, perfect cycle of turning waste right back into power.
All right, so how do these two halves work together to create this non-stop cycle of power? Understanding this flow, well, that's where you really get to see the magic of the turbocharger in action. Okay, here's the play-by-play. Step 1. Hot exhaust gas shoots out of your engine. Instead of just going out the tailpipe, it hits the turbine and makes it spin. Step 2, that turbine is connected to the compressor, so the compressor starts spinning like crazy too. Step 3, the compressor acts like a vacuum, pulling in fresh air and pressurizing it. Step 4, all that dense, oxygen-packed air gets forced back into the engine's combustion chamber. And finally, Step 5, with all that extra oxygen, the engine can burn more fuel, which creates a much bigger bang, and that gives you that awesome boost in power.
But wait, there's another clever piece to this puzzle. See, when you compress air, it gets hot. That's just physics. And the problem is, hot air is less dense, meaning it has less oxygen. Kind of defeats the purpose, right? So, to solve this, a lot of turbo systems have what's called an intercooler. Just think of it like a little radiator that cools down that hot, compressed air before it goes into the engine. Cooler air means denser air, which means an even bigger bang. And hey, by the way, this whole process is why you sometimes hear about turbo lag. That's that tiny delay you might feel before the power really kicks in. It's just the time it takes for the exhaust gas to get that turbine and compressor spinning fast enough to do their thing.
Okay, so now that we've got a handle on how this really elegant system works, let's talk about the why. Why is it so popular? Well, the real-world benefits are, and I'm not exaggerating, totally transformative for modern engines.
I mean, this is really the ultimate win-win, or maybe even win-win-win scenario. First, obviously, you get a huge increase in power. But, and this is so important, you also get much better efficiency. Because you're using energy that was just being wasted, the engine itself doesn't have to work as hard. This has led to something called engine downsizing. Basically, car companies can now swap out a big, thirsty V6 engine for a small, turbocharged four-cylinder that actually produces the same amount of power. And that is a huge reason why modern cars can be so fuel efficient without feeling slow and sluggish.
Look, if there is just one thing you take away from all this, let it be this right here. The core magic of the turbocharger is simple. You are getting more from less. It's just this incredibly elegant engineering principle that has completely, and I mean completely, reshaped the car world over the last few decades.
But, of course, as we start looking towards the future, an electric future, you have to wonder, right? What happens to this incredible piece of internal combustion engine tech? Does the magic of the turbo just fade away?
Or could the core ideas behind it, boosting power and efficiency, somehow find a new life in the next generation of vehicles? It's definitely something to think about.